topic is oxyacids of sulphur. Very important topic and very easy topic also. Here oxygen, sulphur and hydrogen also added here. So here acids are formed, sulphur acids are formed. There are several types of oxyacids of sulphur. So they do not exist as free acids. These are not just like normal acids, as free acids. But their anions and salts are, we know. Salts are, we know. Okay. So these are mainly divided into 5 types. Oxyacids are 5 types. Okay. So here first one is sulfoxylic acid, and the second one is sulphurous acid series, and next sulfuric acid series, and the next fourth one is thionic acid series, fifth one finally peroxy acid series. Okay, so here sulfoxylic acid. So here subgroups are here, that's why we are calling this one series. So here only one example, that is sulfoxylic acid. Here in sulphurous acid series we have 3, and here also we have 3 examples. Here thionic, just only two. Remember this sequence. Okay, here sulfoxylic acid, this one structure, just based on our syllabus only, he is asking only structure, not about any theory questions are here. So here sulfoxylic acid structure, what is the first formula? H2SO2. So here structure of H2SO2 is sulfur form. How many bonds? 4 bonds we know. So here how many OHs are here? How many H's are here? 2. Okay, so here OH, here double bond O, here double bond O, 2 oxygens are completed, remaining is H. This one will be structure for the sulfoxylic acid. Next, sulphurous acid. We know sulfuric acid formula, we know, just simply H2SO4. Sulphurous, lossing of one oxygen, sulphurous acid. That means here sulphurous acid formula is H2SO3. Okay. So this one is about first structure. This one is about second structure. Second, in that one 3 examples we have. First one is sulphurous acid. So here that formula is H2SO3. As means less, ik means high, 4. Okay, less means 3 here. Okay, so here structure sulfur, single oxygen and 2 OH. This is about sulphurous series. In that sulphurous series, A structure. B structure is pyrosulphurous acid. Its formula is H2S2O5. Okay, so here structure, how many sulfurs are here? 2. Okay, how many sulfurs are here? 2 sulfurs and 2 H2, that means 2H2 means one side OH and another side is also OH, but OH, one O is left here. How many oxygens are here remaining? 4. So sulfur forms 4 bonds, means here sulfur satisfied, here also sulfur satisfied. So if in case more than one sulfur is present there, maximum that sulfur will be form same bond, similar bond, or extra bonds. So 4 and sometimes 6 bonds also it will be formed. So here 2, this one will be satisfied. So again this one OH. Okay, here O 1 2 3 4. Here 4 oxygens will be here. The next 5th oxygen forming bond here. That means this sulfur form 4 bonds. This sulfur form 6 bonds. Okay. So this is about pyrosulfurous acid. Remember this thing. Okay. Next, C is dithionous acid. Dithionous acid. Its formula is H2S2O4. H2S2O4. Thionous, pyro having SS. Actually thionous means sulfur linkage will be there. Okay, so H2 means OH. 2 hydrogens are completed, 2 oxygens also completed, remaining 2 oxygens. Like this. This sulfur is also 4, this sulfur is also 4 bonds. Okay, that means sulfurous acid is also completed, sulfoxylic acid also completed. Now sulfuric acid formula H2SO4, we know about that one. So structure of sulfuric acid, SOH and remaining oxygens are like this. Okay, 2 hydrogens and 4 oxygens are satisfied here. Sulfur here form 6 bonds. Okay, next in this one A, again B, sulfuric acid. Its formula is H2S2O3. So here sulfur, 2 hydrogens, maximum may be satisfied, OH, remaining double bond O and remaining S. Okay, here sulfur satisfied with 6 bonds, here sulfur only 2 bonds. Okay, 3 oxygens, 2 and S2. So this will be satisfied. Next one, pyrosulfuric acid. Its formula H2S2O7. Remember H2S2O7. Here structure is pyro, sulfur, same. Pyro means middle of oxygen between 2 sulfurs, pyrosulfuric acid. Okay, 5 oxygens are left. Here 2 hydrogens, 2 oxygens, OH. So this is about pyrosulfuric acid. Okay, what is the geometry of these? This one is simple. In this one, these all are having the bulky structure. So what about sulfurous acid, main sulfurous acid geometry? See here, geometry of this sulfurous acid has double bond O geometry. Simply we are drawing like this. Okay, lossing of hydrogens. 1 hydrogen loss, minus charge, 1 hydrogen loss, minus charge. This one will be double bond, and sulfur having the lone pair of electrons on that one. This one will be the geometry of this thing. Here H2SO4 is very important, you know. So here also having the geometry. Remaining things are also having geometry, but we just explained about which are important one. Okay, so 4 oxygens are here, oxygen, geometry like this, imaginary lines. 2 oxygens are lossing off here minus charge, here minus charge, remaining 2 are double bonds. In thionic acid series, we know 2 examples are here, and peroxyacids are, we have 2 examples are here. Here first one is a thionic acid. Here example is H2S2O6. So here 2 thionic, thio means SS linkage will be having. So then next OH ending, this OH ending, remaining 4 oxygens are like this. That means each sulfur forming the 6 bonds, 6 bonds. Okay. Then next B. So B, polythionic acid. In polythionic acid, what is the example? H2SnO6. That means it is a polymer. That's why polythionic acid, polymer. So here sulfur, same forming of 6 bonds. One side OH, S, N times. Again same structure will be repeated. So breaking of this compound, middle just place the Sn. Okay, it will be formed. Okay, simply. Okay, here N is equal to 1 to 4 we have to take in. Okay, then next peroxy. Peroxy disulfuric acid. Formula is H2S2O8. Okay, peroxy means, thio means SS linkage, peroxy means OO linkage. OO. Again sulfur, sulfur, OH, OH. 4 oxygens are left here. Remaining 4 oxygens are double bond O, double bond O, double bond O. So structure will be completed. Remember one thing, OO linkage is called peroxy linkage, SS linkage is called thionic linkage. Okay. Here next B, peroxy mono sulfuric acid. Sulfuric acid. Formula is H2SO5. H2SO5. Only one S. This side OH. Oxygens are how many? 5. Peroxy linkage means OO linkage will be formed. That means OO linkage will be formed here. Yes. So here this one is special here, Sn. So what is the geometry of this thing? S. Always here forming 6 bonds. Imaginary lines. Here lossing of H plus. Here how many S's are we are taking? Up to 4. Middle. Sorry. Imaginary lines. Double bond S. O. O. Double bond O. Okay, this one oxygen will be lossing of 1 hydrogen. So like this, these structures are having Sn, n times. Okay, here structure of peroxy linkage. So here peroxy linkage A. So here sulfur, oxygen, lossing of hydrogen, O, O, OO linkage, S. Okay, imaginary line, draw the imaginary line. Okay, like this. Here double bond, here double bond, here double bond, here double bond. Here lossing of hydrogen. Okay, so this is about peroxy linkage. So